Everyone, and welcome to our Tomorrow's Talent Series Q&A. My name is Dana Toomey, and I'm an Assistant Director with Michigan Technological University's Center for Educational Outreach. The Tomorrow's Talent Series is about showcasing in-demand careers through virtual job shadowing videos, Q&As, and curriculum resources. Today with us, we have Jake Zielinski from Westfall Technik. Jake is a journeyman mold maker, and we're going to be learning a little bit more about his career in manufacturing. So for those of you who haven't had the opportunity to watch the full video yet, make sure you take a look at our website. The full video is there, and the recording of this Q&A session will be posted as well. So throughout the Q&A today, you will have the opportunity to ask and submit questions. You can find that Q&A bottom at the bottom of your screen. So, Jake, how are you doing today?
I'm doing well. How are you?
Doing well. So to just jump in, can you tell us a little bit about your company and the products that you make?
So at Westfall Technik, located in Wakefield, Michigan, we make plastic injection molds. What a plastic injection mold is it's typically you have a plastic part, and molten plastic is injected into that part under pressure, and there's a big steel cavity that holds everything and makes a plastic part. So we manufacture the molds, and we actually run production on the molds that we make.
Great. And can you tell me very simply what you do as a journeyman mold maker?
Yeah, so as a journeyman mold maker, I'm responsible for seeing all new tooling projects through the shop in manufacturing. In the video that we created, virtual tour, you'll see many of the machines that we use to make a mold. So I'm pretty much responsible for seeing that all the components get manufactured to spec and assembled correctly, and then send the tool to our molding facility and make parts. Easier said than done, but that's kind of a short version of what happens.
And what does the journeyman portion of your title mean?
The best way for me to describe that would be like a journeyman card is almost like a bachelor's degree for a trade. So I went through an 8,000-hour apprenticeship with online schooling and 8,000 hours of shop time. I also had to take a 500 question exam at the end of that time and get like a B or better, 80% or better. I was awarded my journeyman card. You touch every area in the shop, so I'm able to run every piece of equipment at our facility, which makes things which makes me valuable, and that's a great thing for anybody looking to start a career in this field.
Wow, that's great. So you mentioned all the different machines in the video. We see some footage of milling machines, of a surface grinder, a hole shooter, a sinker EDM machine. Do most of the molds that you make go through all of these different machines, or was that just specific to the mold that we saw you creating?
Yes, mostly everything goes through those machines almost in that operation, or in order of operation as the video showed. Or it would start out with a soft piece of steel, roughing it, then grinding, milling, sinker EDM, and then assembly.
Are there any other machines that you frequently use that we didn't get to see in the video?
One thing we didn't show you guys was the heat treat ovens. Typically, when you're roughing out a piece of steel, it's soft, so like 35 Rockwell. We typically harden our blocks anywhere from 50 to 60, depending on the type of steel. So you always want for production tools like that are going to run like millions and millions of shots. That means every time the mold opens and closes, we call that a shot. So the harder the steel, the more wear resistant it is. That was the one thing we left out just because it looks like an oven baking something.
And you said that you know how to operate all the machines. Do you have a favorite?
Yeah, I would say surface grinding. I like it because it's super accurate and you're in total control. It's a total manual machine. Whereas like a CNC mill, you are relying on either yourself to program it or someone else. One thing I should say is our shop is so big that we've departmentalized. So like I don't do run all the machines every single day. We're in a smaller mold shop. You're the journeyman mold maker. You literally run every machine on every single piece of steel. In my role now, I don't operate the machines daily.
Okay. So you talked a little bit about your training to get to where you are, but how did you start out at Westfall Technik?
So I started from the bottom up. I had a connection into this company through a family friend, and I got hired when I was 16 years old. All I was doing was manual labor, janitorial work, operating presses, just grunt work. That was when I was 16. And then the summer going into my senior year of high school, I was actually planning on being a mechanical engineer. And so they hired me on as an engineering intern where I worked in mold design, learned our design software, thought that was very fascinating. And I actually had plans to go to Michigan Tech after high school. However, I decided to go to community college, intern here, stay at home, live with my parents. And then I just kind of fell in love with the trade after I started spending time on the shop floor, and that's where I fell in love with mold making while I was taking engineering courses.
And obviously you've stuck with it. So what are some of your favorite aspects of this position that kind of drew you away from engineering and more to the trade side?
Okay. So the engineering part is very fascinating. I mean, but you're sitting at a desk for 10 to 12 hours a day, and I was not digging that. With mold making, you're using a lot of science, math, trigonometry, but you're also moving around and using your hands. That's a big thing. It's very meticulous work, but you're still moving around and using math and science. That was a big thing for me.
But it sounds like you still get to work with a lot of other positions. In the video, you kind of mentioned design engineers, automation engineers, process engineers, and quality engineers. So it sounds like maybe there's a different path into each of these different specific career types, but you all work together frequently. Is that true?
Yes. So like as a mold engineer or a mold maker, uh, typically our project team is the journeyman mold maker, the design engineer, the process engineer, and then a quality technician. So I went with the mold maker route where I did a 4-year apprenticeship, went through the shop, learned the whole trade. Um, I could have gone to Michigan Tech or any other Ferris State, any other engineering school to become an engineer and go to the design route or a quality technician route. And then process engineers, that's kind of more like that's the plastic side of the business. I think one of the few places that offers that is just Ferris State. I don't think like Michigan Tech or Northern have anything like that for plastic processing.
Luckily, we are diversifying some of our offerings in manufacturing, so that could be really exciting. They're just getting started here, but
It would be awesome.
um, so with the products that you create, are you able to use like, does a mold for one company, could it be used for another company, or is each product's mold unique? Each brand have a
Yeah.
unique mold.
Yes. So we have a huge variety of customers, global, anything from the automotive industry, electronics, medical, consumer packaging. Uh, so typically, yeah, customers aren't using each other's molds or parts or anything like that. It's we build a mold for a customer, let's say like Nipro, they're big into the medical. They would only use that tool. They would run production after we get done sampling it, or and it would just stay in their facility.
And Do these molds wear down over time when they're used in production? Do they have to be replaced frequently?
Uh, they do have to be replaced, but hopefully not frequently. So like typically we offer a one 1 million shot warranty. So if the mold malfunctions or something breaks and it has under 1 million shots on it, we'll fix it for free. Over that, we'll fix it, but we'll charge typically. That's kind of standard throughout the industry.
Got it.
1 million shots, that's quite a bit. Steel does wear, and we're talking like tenths of thousands, so 0.0001. But that in the plastics industry, that can make a big difference.
Wow. In the video, we saw a piece being polished by hand. Is that usually how everything is polished?
Yeah, that's really the only way to polish steel is by hand. So that's as the trade has developed over time, we've gotten away from more and more manual processes where it's become more automated, like with CNC machines. But yeah, polishing is one of the few manual processes left.
Uh,
And that's actually another career that we hardly even touched on in the video. You could be a polishing technician and make that a career and be very well off. It really is an art, honestly. I mean, I can do it all right, but the guys that are really good, it's something special to see, especially when you're going into super high finishes like diamond polish, where it's like a mirror. You can actually see your reflection. It's pretty amazing.
wow. Can you expand a little bit more on how automation is being used in this field, or what things are still being done manually?
Yeah, so automation is definitely taking over. Um, Honestly, we're trying to automate everything that we can just because it's more efficient and saves so much time. So like typically the ways we would normally machine set up blocks in like a CNC machine, you'd have to like manually tram it in, pick it up. Well, now we're doing stuff with like robots where we actually have the workpiece mounted on a fixture and a robot picks it up and sets it in a chuck. So there's great repeatability and hardly any, it's taking the human out of it almost. You still need humans to run the machines, but it's a lot less manual work.
So really technical work now.
It's very technical, yeah. Lots of computers, electronics.
And even with the automation, what are some of the parts of the mold making process that are the most time intensive?
Uh, what's that? Time
Time
consuming?
intensive, yeah. What stage takes the longest in making a mold?
Well, as far as the machining side goes, Sinker EDM is a very slow process, but it's a very accurate process. Uh, that's why we try and CNC machine everything that we can because it's much faster. So if you have to burn something in the Sinker EDM, that would be the longest machining process. But as far as like the assembly, hand working and polishing for tool makers, that takes the longest time. I know we try and say that you never have to fit a corner or break an edge, but even when end mills break down, electrodes break down. So there is some hand working, although we try and avoid that at all costs.
So you're talking about such a precise measuring and check for accuracy in your products. Um, is it common that you often have to get down to that precise of a measurement? Does it vary between the industry that a mold is going to?
Yeah, I mean, that's the other variable, resin. Depending on the mold, every different mold, every different part typically has a different resin. So if it's like a super thin resin like polypropylene that flashes at a half thou, flashes a plastic defect, that's when you have to start hand working and getting very, very meticulous. Where if it's a polycarbonate, that's a thou and a half, you can just usually machine your parts and call her a day.
So you're talking about the materials that the mold themselves are made of, which is actually a question that one of our viewers have. What are the most common types of materials used to create a mold?
So there's tons of tooling steels out there, tons of different types of alloys. Usually S7, A2, H13 are the most common tool steels that we use here at Extreme. So we're building like high volume plastic injection molds, so like over 1 million shots. You'd want a hardened piece of steel. Lower cavitation, lower volume molds will use like a P20, which is a softer steel, or a pre-hardened steel. Um, that's tool steel. And then, like I said, you have plastic resins. There's thousands. Polypropylene, polycarbonate. Those are just two to name it. Those are just two easy ones.
So why do companies use molds as part of their manufacturing process? What are some of the pros and cons of using a mold?
Just volume, pure volume. So like if you wanted to make a plastic part and you tried 3D printing it, or took a raw piece of plastic, Delrin or something like that, and you tried to machine the part, you would never keep up to the demand of volume. So injecting it into a mold is the fastest way to do it right now.
Got it. So what happens to the molds when they leave your facility? Like, how many molds are you actually shipping out the door to a certain customer? Is it just the one set that we saw in the video? Is there a whole nother palette that we didn't see?
So like the one that we showed in the video, that was a smaller tool. It was only a 4-cavity mold. That means every time the mold opens and closes, it pops out 4 parts. We probably build 100 of those a year, and then we do maybe like 50 bigger ones. We've been growing every year, so the number keeps going up. But it's like we built as big as 64 cavity tools. And those things are huge. I mean, they're probably like 8 feet by 6 feet wide and tall, 8,000 pounds. So, I mean, big ones.
So if we were to go to the next facility where they're being used to actually make products, would we see like a line of them, or what would that look like?
Well, we have, I'd say, probably 30 to 50 molds kind of in a warehouse in the back on pallets, ready to go. What we've done in the past is, depending on the customer, they will actually leave the tool here and we'll run low volume production. And then some customers, we sample it, develop a plastic process, and then ship the tool out for higher volume production. It just depends on what our customer wants.
What are some of the challenging aspects of your job, and what problems do you solve?
Well, I could go on forever. Molds are a challenge. Typically, the biggest thing that I fight in my job is plastic defects. So when a mold goes over, it samples. The whole team gets together. We call out any defects that we see. Typically, I would say flash is the most common one. It doesn't matter where you go, any facility, they're going to say that. That's like where you have a bad shutoff, where you actually didn't machine the steel tight enough, or your pack pressure is too high on your molding process, so you're blowing open the tool, so there's like a design error, stuff like that. We strive to make a perfect part every time, but it doesn't always happen.
Do you think that problem solving is a really big aspect of your job?
Huge, huge. Problem solving and critical thinking. If you have those two skills and you're willing to work hard, and if you have a meticulous attitude, meticulous just in nature, you will do well in this trade.
So on that note, if you could use only one word to describe people in your field, what would that word be?
Dedicated. I know it's like this in pretty much any mold shop you go throughout the world. You know, in the United States, in Europe, in China, mold makers are dedicated. Typically, if we have a customer deadline to hit, we don't stop until that mold is done. I mean, we don't always get it on time, of course, but we're gonna really bust our tail and do whatever it takes to try and get it on time. I mean, I've worked anywhere from 21 hours is the longest shift I've worked, and that's not the norm, thankfully, but we do everything in our power to get the job done on time to make a happy customer.
I think dedicated is a very accurate word then. So we talked a little bit about automation and how that is, changing the field. What are some other ways that your work has changed since you started?
I would just say technology in general and like paper. When I started, we used all manual paper prints. Now everything's on the computer. We're completely paperless at Westfall. That's one nice thing. And then just technology is constantly evolving. So tolerances are getting tighter on plastic parts. So that means tolerances are getting tighter on our molds. So that's happening. Then our machines also, we have to buy better machines. So getting more and more meticulous, which is a good thing. Better products.
What advice would you give to students who might be interested in going into this field?
Try and job shadow. If there's even a machine, if it doesn't even have to be a mold manufacturing facility. If it's just a machining facility or a mold manufacturer or a plastics facility, try and job shadow. If your school or college offers a trades program for machining, that looks like something that you'd be interested in, enroll, give it a shot. I we never had machine shop in high school, and I was lucky enough to come on board here at Westfall when I did. So just learn everything hands-on on the job. That was great, but everybody might not have that opportunity.
I think your story of, finding something that you were passionate about too and that fit your career goals and the type of work that you wanted to do, being hands-on and not moving around, is also a really important message for our students. And I'm really glad that you talked about that earlier, is, finding your fit within
Right.
the field.
Yeah, definitely one thing that I want to touch on is, like, when I was in high school, everybody geared me to go to college. You got to go to college, So that's why I was initially thinking, okay, I'm gonna be a mechanical engineer or some kind of engineer. And then I started working on the floor, like math and science, working with my hands. I mean, I love it. So there's lots of opportunities out there in trades. And I'm not bashing college at all. I'm actually going to college on the side right now, business. Still do my shop work and mold making. It's good, and I get to do it in a place that I love.
You got to find the fit that's right for you, whatever that path is.
Even if your parents get mad at you, don't push you around, because I told my dad I wasn't going to be an engineer and I was not going to go back to college after my third semester. There was some hard feelings for a while, but everything worked out. And here I am, 7 years later and doing well.
Is there anything else that you'd like students to know about this field that we haven't discussed yet?
We covered pretty much everything. I mean, there's just lots of opportunity. I mean, tooling's coming back to the States. People want their molds manufactured in America just due to the quality of molds that we build. So there's tons of opportunity.
Great. Well, thank you so much, Jake. And I just want to thank you again for joining us today and giving us a deeper understanding of what it means to be a journeyman mold maker. For those of you watching us today, thank you for tuning in. We are going to be releasing more job shadowing videos and hosting more Q&As throughout the year, so keep checking back at our website. I also want to say thank you to our other partners, MySTEM Network, Michigan Works, Bay College, Gogebic Community College, and our CTE directors. Thank you, Jake. It's been a pleasure.
Thank you.
Bye.
Bye.